Traceroute is a way of following the path a packet takes through the network. Traceroute uses standard technology implemented in all IP hosts and routers, so it can be used almost anywhere. Traceroute is important as a diagnostic tool since it allows us to watch which routers a packet passes through while traveling from its source to its destination. This helps us diagnose network problems, both in terms of path and delays. An important feature of Traceroute is that it can be done without any passwords or special access to the intermediate routers. In addition, Traceroute methodology is used in Skitter and other internet mapping projects to find internet connections between routers. Each line number of a traceroute may show the hop number, host name, IP address of the router, followed by round-trip times. Here's how it works. Below is a mock example of a network packet. Each packet that is sent through the network has a TTL, or time to live. Time to live is measured in the number of hops a packet may take before being discarded by the network. Each time a packet reaches a router, the time to live is decremented by 1. The ICMP request specifies what kind of response the packet would like the router to send back to the source. Normally, a packet will reach its destination before the TTL hits 0. The destination host replies to the sourced host's ICMP request with a response packet. The next example shows what happens if time to live is exceeded. The time to live decrements at each router. If the time to live hits 0 before the packet reaches its destination, a message is returned to the source router telling it that the time to live has expired. To find routers along the path, Traceroute sends packets with different time to live to the destination. For example, in this diagram, when a Traceroute host receives an error at host B on the way to its destination, such as time to live expired, the error message lets Traceroute know that host B is 1 hop away. This is repeated for each host. Once the error message is received, Traceroute prints the host information and round-trip times for that hop. If a packet gets lost on the return trip to the source, Traceroute prints asterisks in the round-trip time fields. This can happen if there is no answer from the destination, if there are dropped packets due to network congestion, or if the router is configured not to send a reply. Problems do exist that limit Traceroute's ability to report accurately on network routes. Asymmetry in routes the packet takes may affect Traceroute reporting. This may happen, for example, if the return trip for the reply from the destination takes a different route than the original packet. Since Traceroute can only see the forward trip, it cannot detect problems on the return trip. Excessive delays or other problems may occur on the return path, so you might be led erroneously to believe the problem is on the forward path. Reverse traceroute databases attempt to tell you the reverse routes, but these are not widely available. However, Traceroute is still useful in locating network problems. Network researchers combine multiple traceroutes to try to discover connectivity of the internet. Caida is using the traceroute methodology inside Skitter to discover the topology of routers and links between machines. Caida has also made gtrace for showing visually the path from your machine to other hosts.